Hold up. Wait a minute. Something ain't right.
Let's have a look at how to make a fairly accurate estimation of the square root of a number. We'll start with a number, and what we need to do is look for the square root of the previous perfect square, the previous square number. We'll go through a couple of examples in a sec so you can see what I mean. Next, we're going to find the leftover between what we got in step 2 and the number, and we're going to divide that by twice the result we got in step 2. And to wrap it up, we're going to put the results from steps 2 and 3 together. And that's our answer. It will be a fairly accurate estimation of the square root. Now, these steps might not sound all that clear, so let's just go through some examples to hopefully make it more clear. Firstly, we're going to start with a number. So our number is 32. We want to know the square root of 32. Well, hopefully we realize that 6 times 6 is 36, so it has to be less than that. So we choose the square root of the previous square. How about 5 5s? Well, that's 25, isn't it? So the previous perfect square would be 25, and the square root of that is 5. Our final answer is going to be 5 point something. It'll be 5 and a bit. But now we need to know what that bit is. So we find the difference between 25 and 32. Our difference here is 7 because 25 plus 7 takes us up to 32. Now we need to divide that by twice the result we got from the second step, which was 5. So that 7 is divided by 2 lots of the 5, so divided by 10. So we have 7/10. Our answer is going to be 5 7/10, or 5.7. If we actually plug into a calculator the square root of 32, we get the answer of 5.657. So you can see our answer is actually really close to what the calculator gives us. In fact, if we were working to one decimal place, then it's the same as what the calculator gives us, 5.7. So hopefully that started to make things a bit clear, but we'll go through a few more examples as well. Let's start with the number 68. We need to find the square root of the previous square. That would be 8, because 8 8s are 64, 9 9s are 81. Well, no, that's too high, so we have to go with the 8 8s, 64. So that gives us 8. Our answer is going to be 8 point something, or 8 and some fraction, 8 and a bit. The difference between 68 and 64 is 4. So we're going to take that 4 and divide it by twice the 8. So 4 over 16. Now that is just a quarter. So our answer is 8.25, 8 and a quarter. Now the calculator will tell us that the square root of 68 is 8.246. Well, that's very close, isn't it? It's about 8 and a quarter. In fact, if we went to 2 decimal places, it is 8.25, the same as what we got. Next number, 87. Well, we mentioned in the previous number that 9 9s are 81, and hopefully we know that 10 10s are 100, so that's too high, so we'll go with our 9. We have the square root of 81 gives us 9. Our answer will be 9 and a bit more. The difference between 87 and 81 is 6, so we're going to divide 6 by 2 lots of 9, so 6 over 18. We can simplify that fraction to 1/3, so our answer is going to be 9 1/3, or 9.33. Calculator's answer, 9.327, which is 9.33 to 2 decimal places. Another number, 118. You can see I'm getting larger and larger numbers, so we can see this does actually keep working. Now, 11 11s are 121. Well, that's too high. Let's go for 10 10s. That's 100. So there we go. That's the square root of the previous perfect square. The previous perfect square being 100. The square root is 10. Our answer will be 10 point something. What's the difference between 118 and 100? Well, the difference is 18, and we divide that by 2 lots of 10, so we have 18 divided by 20, and we could simplify that to 9 over 10, and that, of course, is 0.9, so our answer is going to be 10.9. Calculator's answer, 10.863. If we took that to one decimal place, that's 10.9. same result. Another number, 157. Well, 12 12s are 144, 13 13s are 169. Nope, that one was too high, so we'll go with our 12. So our previous perfect square is 144 and the square root is 12. Our answer is going to be 12 point something. The difference between 157 and 144 is 13. So we have 13 divided by 24, which is 2 lots of 12. Our answer is going to be 12 and 13 over 24, 13 24ths. If we convert that to a decimal, we have 12.542, which is very similar to the calculator's answer. The square root of 157 is 12.530. So not exactly the same, but that's okay. We're estimating. We want a fairly accurate estimation, which is exactly what we have. Another number, 186. Well, as we said previously, 13 13s are 169, so that's going to be our previous perfect square. So the square root of that, 13, our answer is going to be 13 point something. The difference between 186 and 169 is 17. So we have 13 and 17 divided by 2 lots of 13. So 13 and 17 over 26. If we convert that to a decimal, we have 13.654. 17 over 26 is 0.654. And we can see that that is very similar to the calculator's answer. The square root of 186 is 13.638. So our 13.654, that's a pretty good estimation. Another number now, 417, getting larger and larger, as I said. 20 times 20, 2 2s are 4, so 20 20s are 400. So 400 is going to be our previous perfect square, and the square root being 20. Our answer for the square root of 417 will be 20 and some other little bit, 20 point something. Now the difference between 417 and 400 is 17, so we have 17 divided by 40, because 2 lots of the 20 is our 40. So our final answer is 20 and 17 40ths, which if we convert to a decimal, 17 40ths gives us 0.425. So our answer is 20.425, which you can see is very close to the calculator's answer of 20.421. Final number now. I think we've done enough that hopefully you're getting the hang of this. So to wrap it up, we have 10,123. Again, just trying to go larger and larger to show you that, hey, this method keeps working. So let's pull out 100 squares. That's 10,000. Okay, as our previous perfect square. So the square root of 100, our answer is going to be 100 point something. What's the difference between the number we started with and 10,000? Well, the difference is 123. What's 2 times 100? Well, that's 200. So that leaves us with the extra bit being 123 200ths as our answer. Now, if we convert 123 divided by 200 to a decimal, that's 0.615. So there's our final answer, 100.615. What does the calculator say? 100.613. Very close for an estimation of the square root of 10,123. That's pretty good, I'd say. So there you go. That is how to get an accurate estimation of the square root of a number.
If you like this video, punch that like button. If you want to see more videos, smash that subscribe.